In this fourth part of our section number 2, Theoretical Backgrounds, I will present you the last slides. Therefore, it is highly recommended that you understand how the equation of the model of diamond was derived, because on that I will now continue in order to explain you topics like risk premium and also the importance of the punishment function. We'll analyze at the end the situation of the debtor as well as the situation of the bank in order to understand how we can explain the existence of banks due to the model of diamond. At the end of this section we will have an expanding of the model of diamond, where we will analyze the influence of taxes or subsidies on the repayment function of our model of diamonds. Therefore, 3 slides are available in Moodle for download. Let's start with the presentation of the last slides. Let's start with the analysis of the punishment function. So the punishment function is the means to ensure that our debtor tells the truth. So he has the choice either to repay in euros or to repay in slabs, and he has a slightly preference in favor of the euros. That means in order to minimize the amount of slabs he receives, he reports the truth and pays as much money as possible to the bank, of course not more than RC. We have no other means, no other function in order to ensure the true reporting of our debt. We have to analyze the situation of the bank. The bank is offered 2 alternatives. One is a riskless investment with the repayment of I, so here certainty, and on the other side we have the risky loan, where the bank can either receive a higher repayment of RC, but in case of the loss there is a payment which is lower, so that on average or as expected value the expected repayment of the loan must equal at least the riskless investment, as we assume the bank to be risk neutral. So in that case we analyze what is the expected repayment in case of no full repayment. That's the synthetic rectangle we created, and on the other side what is the repayment in case of full repayment, that is the contractual fixed payment. We consider the 2 probabilities and compare the situation. At the end, our debtor has to pay more than I, and that is the so-called risk premium. The risk premium which shall cover the expected loss of our creditor in case of a no full repayment, and of course the risk premium will be the higher, the bigger the probability is of no full repayment, and of course the bigger the extent is of the loss in that loss case. So we can generally state that the risk premium, which is the difference between RC and I, will increase with, for example, a smaller Y min and a bigger probability of a loss. What are the costs which are caused by the model of diamond? Firstly, as in every principal agent problem, the so-called information costs. Because we are not able to obtain the first best solution, we must accept the second best solution. The first best solution would be that we implement an average repayment which equals I. That is of course implemented in our model, but additionally we have also the punishment function, which is costs for our debtor, because in case of no full repayment he suffers the slab, and that of course is for him a disutility, and therefore these are costs to be considered in our model. We have the risk premium, which is included in the model in order to ensure that our bank is compensated in the case of a loss event by a higher repayment in the case of a no-loss event. So that is due to the status of asymmetric information. What else could be implemented? For example, we could include a monitoring system that we have, for example, an auditor, that's somebody who supervises the outcome of the project, so that at the end there is a check of the statement of account of our creditor, and that of course causes costs. So every of our creditors has to monitor, and we have a lot of costs at the end. Here, that is not a means to be implemented. The punishment function as a kind of costs only for the debtor, that is here our best solution in order to ensure that the costs occurring in the model and guaranteeing true reporting are minimized. But one aspect has to be discussed further. So we solve the issue of no correct reporting between the bank and the debtor. But we have a similar issue with regard to the creditors, so the persons who make deposits at the bank. So here there's also the risk of false reporting, and this false communication must be excluded. So therefore, what do we have in reality? It's that we have here an institution which monitors the bank, that is banking supervision authorities. Of course there are costs, but we have here the monitoring costs decreased from M times C. That is a monitoring by all the creditors of the bank. To C, it only occurs once, and as we have some rules provided by banking supervision authority, there is the effect that the average risk of a single deal decreases. In other words, the more the bank invests into a diversified portfolio of several loans, the lower is the respective risk for the single creditor. And you can show statistically by the so-called convergency of probability that at the end, if we have a portfolio with a very big number of debtors, that in that case the average deposit contract does not bear any risk. Of course the risk is still there, but is neglectable small, and because of this effect, at the end we can assure that the bank is safe and always able to repay the deposits to the creditors. This slide summarizes everything which was said before. So here is the argument of diversification. So our financial intermediate, the bank, does not only have one debtor, it has several debtors. So in the bank, she invests into a loan portfolio of 100,000, 1 million loans. As we have the punishment function in the model, or also as a substitute the monitoring costs, we can ensure that here our debtors will tell the truth. And because of this portfolio, we can argue that at the end, the contracts on the other side, where the bank is the debtor and the saver is the creditor, will be safe, so that at the end, the risk premium which is paid by the bank decreases to zero because of the portfolio effect, so that at the end, the single deposit contract between the creditor and the bank does not bear any risk. And that is at the end the argumentation why banks exist. So banks exist mainly because of the transaction costs and because of their ability to grant more than one loans, to grant a loan portfolio, and therefore have at the end on average a reduced risk. That is the end of our chapter number 2, theoretical background, the end of the teaching. But for some training purposes, there are some special cases which for now will be analyzed. They are called the model of diamond and taxes. On the slide you see the well-known figure of the model of diamond. So we have in blue the repayment function. You see that it is an increasing function with regards to y, so the higher the project return, the higher will be the repayment, and having reached the level of RC, there is a constant repayment to the bank. Currently we live in the perfect world of our model, but let's enhance that by two analyses. Firstly, what is the effect if we now add a project tax? That means that for the implementation of the project, a tax has to be paid, and the tax is independent of the project return. So think how the repayment functions to the bank looks like in the case of a project tax, and therefore I kindly ask you to stop the video. What is now the effect of a project tax? That means that out of the project return y, let's assume the project return is 40, we have to pay the tax. Let's assume the tax is 20. That means if our project return is 40, we are able to repay 20 to the bank. In case of 60, we repay 60 minus 20, 40. In case of 100, repay 80. Comparing this situation with the situation before, in any case the bank will receive less repayment. That means that compared to the situation before, the probability of a loss case increases, and therefore the contractual fixed repayment of the bank increases. In other words, what you have to do is to compare the situation ex ante and ex post. So what happens if I analyze the equation I equaling expected repayment to the bank? Before we said indifference, but with the tax, the alternative loan is less attractive, so in that case the bank would prefer the riskless alternative. In order to increase the level of attractiveness of the loan, I have to increase the contractual fixed repayment. You see here that I have a parallel shift down of the former blue dotted line now to the black line, and that is here the new repayment function. The RC1 new is fictively assumed. You cannot really state how big it is. In a final exam, it's to see where is the edge and what happens to the contractual fixed repayment. The edge moves to the right and the contractual fixed repayment increases. But what happens if we have a subsidy, so that the state says we give you in any case 20 euros to your project in case of having a loss? That is here shown by the purple line. So here we have a movement up. So the situation has improved. What will happen in that case to the contractual fixed repayment? As here our debtor is able to repay additional 20 euros, of course that will reduce the risk. The risk premium decreases and also the contractual fixed repayment. Let's analyze a second situation with regard to taxes. But now we do not assume that we have a project tax which is independent from project return. Now we assume that we will tax the project return from the first euro. So having a project return, for example, of 40 and the tax rate is 25%, in that case you only have 30 euros available for the repayment of the loan. 10 euros are transferred to fiscal authorities. And the question is, how does the figure look like in that case of a profit-dependent tax? Therefore, I kindly ask you to stop the video and think 3 minutes, what is the solution if we add a profit-dependent tax? On this slide you see the result. We have here a change in the slope of the line, so both lines, assuming that y min is 0, would start in the point 0, 0, but due to the charge of the tax, we have only 75% of the profit left. That means that the slope is smaller, and of course that is again a disadvantage of the bank, so riskless alternative would be preferred. In that case we have to increase the RC to a higher level in order to receive again the state of indifference. But what will happen in case of loss balancing? So that is again shown by the purple line. In that case, having a loss, so assuming that the loss is balanced until 100 euros, that we have here, for example, a taxation if y exceeds I, and that we have a loss balancing if our y is smaller than I. In that case, we have an increase, we have more potential to repay the respective loan, and of course in that situation we have the same effect like a subsidy, the respective contractual fixed repayment will decrease. That, my dear students, shows you now the effect of taxes, and that is a typical exercise as number 2 part in the model of Diamond, where we have expanding the models. So we had commission, insurances, Islamic banking contracts, and so on. So at the end we have one single comparison. What is the effect of expected repayment due to the measure I introduce compared to I? Is it more attractive, the situation? So that means insurance contract or subsidy. In that case we have reduced RC and reduced risk premium. In case of a disadvantage due to taxation, in that case we will have a higher contractual fixed payment. And that is the end of section number 2, theoretical background, and we will hear again when our topic will be deposits. Until that point of time, I say to you, bye bye.